Compass includes several device editors. There's a DUT editor, support device editor, and the piston gauge platform editor. Each of these editors can be controlled by rights management, so if you choose, you can have a lab manager define who can access which feature when. So this is designed to comply with regulatory compliance issues. So I'm going to access the DUT editor. You can either use the DUT shortcut menu on the toolbar or go to the setup menu. Either way, it's the same. This is a DUT editor, but before I talk about the one that's displayed, I want to talk about a few of the features. First off, there's a header tab. So this defines what the device is, who made it, what's its specific identifying characteristics. Calibration defines calibration-specific information. Communications defines the interface of the instrument. So if it's manual, where you're manually going to enter a value, choose manual. However, a variety of other interfaces are available. So there's standard IEEE 48, there's HART communication, there's a macro interface where you can actually communicate with another program. I have the output, which defines the relationship of how the instrument fundamentally outputs to how the pressure is determined. So in this example, I have voltage displayed, so the instrument can output 0 to 5 volts, and that would correspond to 0 to 100 psi. And finally, I have a comment. So if I had specific information on this setup, something that's unique, I can define that in this comment field. Now I want to talk about specifically setting up this pressure module. So there's two ways of doing it. So one way I can manually enter everything. The other way I can actually load the setup from the application example database. So I'm going to cheat and I'm going to load from the application example database. So first step with setting up any device in Compass is to define the label. So I'm just going to call this Fluke module test. If I put in the manufacturer, it's Fluke, and I can put in the model. This is 700 series, or I can select the model for that matter. There's a P08. By using this option, this will go into the Compass's example setup database and load the specifics for this instrument. All the other tabs are now populated with information specific to this pressure module. So if I go to the output tab, I see now there's a pressure range and a selection of a macro that's going to be used to interact with this device. So this range, of course, the software doesn't know the range because I just chose an example. If I double click this field, I can define the actual range of the instrument. I can define the resolution associated with the device. This is very important because if you have the wrong resolution, your data is not going to come out the way you expect it to. So this is the raw output. Again, the raw output is the quantity that comes out of the instrument into the Compass software. The final output, in this case, is the same as the raw output. Compass will read a pressure and respond with the pressure. The reason why there's a distinction is because not all instruments output directly in pressure. And finally, I have a tolerance. By defining a tolerance, I can real-time determine if the instrument is in or out of spec while the test is running. This plot at the bottom will be updated with tolerance bars and the error, and if the error exceeds the tolerance, you'll know graphically while the test is running. The pressure module is actually a complicated instrument. It's one of very few instruments that you have to actually use a separate program for communication. So in this case, communications is defined as by a macro. This macro runs every 500 milliseconds. It calls this Fluke 700 get reading custom macro, and that concludes the specifics of the setup for this pressure module. So I have identified the instrument. I've defined how I'm going to communicate with it. I've defined its output range, so in this case it's 30 psi, and it's going to use this specific macro. So if I save it, it's saved as Fluke module test. If I wanted to, I can also add a comment that would give me specific information for the future. So I've just completely set up the pressure module. So most instruments don't have such a complicated setup. So a more typical example is when you create the instrument, you of course have to identify it, but for communications, macro is rare. Typically it's RS-232 or IEEE 48 or one of the other standard interface protocols. So IEEE is a more common remote interface choice. If I pick IEEE, I can define the specific address, an acceptable timeout, how the device communications are terminated. More importantly though, I can define all the specific remote interface commands for IEEE. So if I choose edit commands, I can create as many commands as I want to read this instrument. So each command I can parse the response to get a specific quantity that I can use while the test is running. So using this combination of features, I can use just about any other host instrument that has a supported interface.